Standard deviation. I'm going to show you how to calculate standard deviation in case you need to refer back to how to do it by hand, and also what standard deviation means. I bought a bag of apples and I weighed them in ounces. Now this nice big red apple right here was 9 ounces. This one weighed 8 ounces, this one weighed 8 ounces. These ones in the back were actually quite a bit smaller than I had expected. This one was 6 ounces, and this one was only 3 ounces, and this one was really quite small, only 2 ounces. So those are my apples. Now the next step is to calculate the mean. So why don't we just do this? I'll list them here. We've got 3, 2, 9, 8, 8, and 6. So I'll calculate the mean, and I do that by adding them up and dividing by how many I have. So I added them up, and there is 36 apples, and I divide that by 6, so the mean is 6. There it is. And we indicate that as X bar. That is the mean, the average of all the apples. Now with the average of all the apples, we're going to move this over here, is we take that average, 6, and we're going to take the average and subtract the mean, the average, from each one of these numbers. Subtract them all. And I'll do that. And we get -3, -4. Let's see, that's 3, 2, 2, and 0. Now you notice if we add those all together, all those up, we're going to add them together, you get 0. So what we do is we square each one of these. So let me just put little squares by there. We're going to square each one of these. So that's going to be 9, 16, 9, 4, 4, and 0. So add those up, and that is 42. So what we do with this is we take that sum and we divide it by 1 less than the number of items we have in our sample. So we're going to take 42 and we're going to divide it by 5. 1 less than all these numbers over here. Now that gives us 8.4. Oops, 8.4. Now that's called the variance. To go from the variance to the standard deviation, because essentially we squared all these numbers, so we're going to undo that squaring, kind of, and we're going to take the square root. So the square root of 8.4 is pretty close to 2.9. And that is our standard deviation. And right now we're going to use this symbol S with a little x. Now that means that we used every single part of our data. So what that means is if we had the average of 6 for all the apples, each individual apple basically has an average difference in ounces from the mean of about 2.9. So that may be a little bit confusing right now, but that's essentially what standard deviation means.